Assalamualaikum and good morning. Today I would like to present my paper Polyconcrete by using recycled Styrofoam as aggregate replacement. For the introduction, polystyrene or EPS foam or Styrofoam is popular plastic packaging material which find wide application in packaging of food items, electronic goods, electrical appliances, furniture, and it also has a very excellent resulting and protective properties. If we look the pie diagram, for the appliance is about 35%, food serviceware about 9%, and the others is 20, 19 and 17%. Polystyrene is also used to make useful products such as disposable cups, trays, cutlery, cartons, and cases for packaging food. Research in Styrofoam. DJ Cooks, in his research, mentioned that lightweight concrete has been successfully used since the ancient Roman times, and its gain is popularity due to its lower density and superior thermal insulation properties. Meanwhile, by Dobrowski, the recipe for lightweight concrete for very light structure is less than 800 kg per meter cube. Meanwhile, the density lightweight for light structure is 800 kg per meter cube to 1,400 kg per meter cube, and the density for the lightweight concrete is 1,400 kg per meter cube to 1,860 kg per meter cube. MH Ahmad stated in his research the highest compressive strength for styrofoam concrete in designs of styrofoam concrete that obtained by using 10 mm² styrofoam and 10% addition of pulverized fly ash. The objective of this research are to determine the characteristic of the styrofoam concrete mixture. Firstly is the slump test, and secondly is fresh concrete density, and third compressive strength. The material used in this research, first is cement, type 1 ordinary Portland cement or OPC, conforming to ASTM C150 by Cahaya Mata Sarawak Cement and Berhad. If you look at the table physical properties, for the cement, the bulk density is 1.2 to 1.4 kg per liter, specific gravity 3.15, particle retained on 90 micrometer sieve 2%, particle retained on 45 micrometer sieve 18%, initial reading time 60 minutes, early strength at 2 days 18 megapascal, standard strength at 20 days 50 megapascal. For the chemical composition, the highest percentage is calcium oxide, is about 64.75%, then silicon dioxide 19.34%, and the others of chemical composition is less than 5%, which is aluminum oxide, ferrous oxide about 3.41%, sulfur oxide 2.85%, magnesium oxide 1.44%, potassium oxide 0.47%, sodium oxide 0.1%, and loss on ignition 3.4%, insoluble residue 1%. For the aggregate, we use the fine aggregate or use sand 4.75 mm maximum size spacing. For the coarse aggregate with maximum size 20 mm. For the styrofoam, the recycled styrofoam tube with size 20 mm used in this picture. If we look the table, for fine aggregate or sand, the specific gravity is 2.61, coarse aggregate 2.65, and styrofoam 0.75. For the bulk density, fine aggregate 1,650.2 kilogram per meter cube, coarse aggregate 1,574.34 kilogram per meter cube, and styrofoam is 34.5 kilogram per meter cube. For the water absorption, fine aggregate is 0.65%, coarse aggregate 0.50%. For the mixture proportion, for the control concrete mixture are containing of 380 kg per meter cube cement, 545 kg per meter cube sand, 1,475 kg per meter cube aggregate, and 190 kg per meter cube of water. For the styrofoam concrete, there was a 3 batches concrete mixture, which is containing 5%, 10%, and 15% sand replacement. Specimen preparation and testing method. For the prepare the mixture, the total specimen is 36 cube molded size 150 mm times 150 mm times 150 mm. Compliance to BS 1881 part 125, which is containing styrofoam 5%, 10%, and 15%. For testing is firstly is slump test, which is determination of concrete workability according to BS 1881 part 102. For the stress density, the average stress density of 3 cubes taken by BS 1881 part 107. Meanwhile, for dry density, measured for cube taken from curing tank prior to compressive test were recorded according to BS 1881 part 1 to 9 for each curing day. For the compressed strength, the cube were tested according to BS 1881 part 116. The average compressive strength of 3 cubes is taken for compressive strength. The results of some tests, firstly CS00, which is 0% or control mixture, is 80 mm. CS05, which is containing 5%, is 60 mm. CS10, which is containing 10%, is 50 mm. And lastly, CS15, which is containing 15%, is 30 mm. The result of stress density, CS00, which is about 2,489 kg per meter cube, CS05 1,557 kg per meter cube, CS10 1498.3 kg per meter cube, and lastly CS15 1469.9 kg per meter cube. The result of compressive strength. CS0 at 7 days is 21.67, for 31 days is 34.67, and 28 days is 26.89. If you look at 7 days for 3 batches, the highest strength is on CS05, which is 2.22, and the difference to control is 89.76%. On 21 days, the highest for 3 batches is on CS10, which is 4.78. If we compare to control, is about 80.62%. And lastly, for 28 days, the highest is 8.67 on CS10 compared to control, which is 67.76%. And the suitable percentage of styrofoam is 10%. For the conclusion, the slump of styrofoam concrete mixture reduced due to increasing of percentage styrofoam content compared to reference mixture concrete. Second, the fresh density of styrofoam concrete mixture slightly decreased below the reference concrete mixture. And third, the compressive strength of styrofoam concrete mixture decreased at 15% of styrofoam adding into the concrete mixture. And lastly, the styrofoam concrete suitable for non-structure as wall of the building. That's all my presentation. Thank you. Lastly, for question and answer session.